Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now, for this question, they want you to find the change in kinetic energy when it moves from x is 0.1 to x equals to 1.2. So what you have to do is go to read from the graph what are your values. So how do we actually find the what do you call it, the KE, right? So think about this, right? So this is actually the graph of potential versus the distance x, right, from the star A. And the point P is actually lies on the line joining. So as the distance x, right, increases from here, all right, then when you move from 0.1 to 1.2, okay, which is here, do you realize that the potential was here, then after that is here? So that means it's getting more negative. That means the potential drops. But how do I find the KE? So again, there is a conservation of energy here. So you'll be loss in GPE equals to gaining KE. Now, unfortunately, your graph is potential, right? Not potential energy. So what do we do? So remember, potential is also can be found by potential energy divided by mass. So potential energy is mass times potential. So since I want change in GPE, which is delta U, I'll get mass times change in potential. So I can use the graph here to find the potential. And then after that, I find the difference. Then I times the mass. And now mass of what? You must times the mass of the rock, which is a test mass here. And you find the change in GPE of the rock. So what you're going to have here is loss in GPE will be mass times change in potential. So if you can read right from the graph, the potential at 0.1 is negative 10. The potential at 1.2 is negative 14. So when you say loss in GPE, so you have to take the bigger minus the smaller, right? So let me just write nicely. So this one will be M, which is the mass of the stone. Change in potential, so the bigger potential, which is negative 10, right, minus the lower potential, which is negative 14, right? So basically, you're going to get 4, right? Don't forget there's a power of 10 to the power 8 there, so don't forget the 10 to the power 8. So that will be equals to gain in KE, which is delta EK. Now you don't need to find the speed, so you can leave it like this. So you substitute the mass here as 180, then this will be 4 times 10 to the power 8. That's how you find your change in K. And if you calculate, you will get as 7.2 times 10 to the power 10 joules. Now, is it an increase, all right, or decrease? State whether this change is an increase or a decrease. So since your GPE is decreasing, so your KE is an increase. All right, so that's your answer. Now, for this next part, it's a bit tricky. They want you to find the minimum speed so that the rock reaches the point of x equals to 1.2. Now, how is this different from the previous part, right? Some people ask me, since I already found the change in KE, can I just use half mv squared equals to the value you just calculated, right now? Seems logical, okay, but there's a trick involved here. Here we're talking about the minimum speed. Now, what does minimum speed mean now? How do I represent these 2 points, right? So imagine you are standing on the cliff, right? Imagine you're standing on the cliff, all right? So you have a certain value of GPE. So when you throw the ball up, all right, your GPE is going to increase. So that will represent this part. Then after that, when it falls to here, so it represents it falls past the cliff, then maybe into the sea. So therefore, the GPE at this 1.2 is somewhere in the sea here. So you will notice that they want you to find the minimum speed you need to throw this to reach here. But to reach here, right, you don't have to give it speed all the way from here to here. You just have to give it enough speed to reach the highest point. Once you give it the speed to reach the highest point, it will stop for a while, then it will fall by itself. So you must give it enough speed to reach the highest point. You don't need to go all the way from here to here. So previously, just now, we were just finding the difference in GPE between these 2 points, all right, in the previous part, and what will be the change in KE if you move from here to here, lah. All right. So here I'm not finding the change in GPE from here to here or the change in KE from here to here. I just want to find the speed to reach this point, the highest point. So all you have to do is you find the GPE at this point, you find the GPE at the highest point, all right, and the difference in GPE will be the difference in KE. That means as you move up from here to here, your gain in GPE will be equals to your loss in KE. So from that, you can find the speed that you need to throw it the highest point. After that, you'll fall by itself. Another reason why we cannot use the previous answer to solve this part is that you have the change in KE between these 2 points. That means you will take the half mv squared here minus the half mv squared here equals to your answer. So this is what you need to find the speed here, but you also don't know the speed here. So because there are two unknowns here, that's why you cannot use your previous answer to solve. Alright, so you can start off by saying loss in KE equals to gain in GPE. So half mv squared, which is the speed that we are going to calculate the minimum speed. So once you reach your highest point, the KE will be 0. Now gain in GPE, be careful though, this is potential. You still have to convert to potential energy. But no worries, because we know that mass times potential is GPE. So the mass times the change in potential will be your change in GPE. So what is the change in potential? Now if you read this value accurately, because 10 boxes is 4, 1 box is 0.4. And if you were to read it, I'll just show you this. You will get a value of negative 4.4. So therefore, if this value is negative 4.4 and this value was negative 10, so the difference will be just either you take the higher one, negative 4.4 minus negative 10, or you just find the difference in magnitude. So 10 minus 4.4 also can, doesn't matter. So 10 minus 4.4 will give you 5.6. So if you're lazy, you can just put that 5.6. Don't forget the 10 to the power of 8. Alright, so you can cancel 1m and then you can find the speed. So if you calculate, you get your speed as 3.3 times 10 to the power of 4 meters per second.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.